In number 1, we want to find the cosine ratio for theta, and cosine is the ratio of the adjacent over the hypotenuse. So the hypotenuse is always the opposite of the right angle. So to find the hypotenuse, we're going to need to do the Pythagorean theorem with the 12 and the 4. So 12 squared plus 4 squared is going to be equal to the hypotenuse squared. So then we're going to square root both sides. And 12 squared is 144, plus 4 squared is 16. And then 144 plus 16 is 160. And then we need to reduce that radical. So 160 is 2 times 80. 80 is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. So circling those in pairs, we have one pair of 2's, another pair of 2's, and then this 2 and 5 don't have any matches. So I can only pull out these two pairs of 2's. So 160, the square root of 160 will be equivalent to 4 square root of 10. So my hypotenuse is equal to 4 square root of 10. So now to find the cosine ratio for the angle theta, I'm going to need the length of the adjacent side, which is the side attached to theta, and that's 12. That's divided by the length of the hypotenuse, which is 4 square root of 10. And then I want to reduce that fraction and rationalize the denominator. So the cosine of theta will be 3 over root 10 when I simplify the 12 and the 4. And then I rationalize the denominator by multiplying by the square root of 10 over the square root of 10 to get cosine of theta is equal to 3 root 10 over 10. And that would be the exact value. And number 2, we want to find the sine of theta, and sine is the ratio of the opposite side over the hypotenuse. So looking at my sketch, the hypotenuse is opposite the right angle, so the hypotenuse is 11. And the side opposite of theta, we don't know, so we're going to need to use the Pythagorean theorem to find the opposite side. So my hypotenuse, C, is 11, B is the adjacent side, and that's square root of 71. So the square root of 71 squared plus the opposite, which is A squared, is equal to the hypotenuse, which is 11 squared. So A squared is equal to 11 squared is 121, minus the square root of 71 squared is 71, and then we'll square root both sides to get A by itself. And 121 minus 71 is 50. So A is exactly the square root of 50. And then I can break that down into a 5 times 10. And 10 is 5 times 2, so I have a pair of 5's and a 2, and I can pull out that 5 then, and the 2 stays under the radical. So the length of the opposite side is 5 square root of 2. So to find the sine of that angle, theta, I take the opposite, which is 5 square root of 2, and I divide that by the hypotenuse, which is 11. And nothing reduces, and there's no need to rationalize the denominator, so that would be my exact answer. Then in problem 3, we want to find the tangent of the angle theta, and tangent is the ratio of the opposite side divided by the adjacent side. So looking at my sketch, the hypotenuse is 9. That's across from the right angle. The side opposite of the angle theta is 6. And then the side adjacent to theta is the one that we don't know. That's the little letter b. So we're going to use the Pythagorean Theorem, and the adjacent side squared, which would be my b squared, plus the opposite side squared, which is 6, is equal to the hypotenuse squared, which is 9. So when I solve for b squared is going to be equal to 9 squared, which is 81, minus 6 squared, which is 36, and we'll square root both sides. And 81 minus 36 is 45. So b is exactly square root of 45. The 45 breaks down into 5 times 9. 9 is 3 times 3. So I have a pair of 3's and a 5. So the b is equal to 3 square root of 5. And that's the length of my adjacent side. So to find the tangent ratio for theta, tangent is the opposite, which is 6, divided by the adjacent 3 square root of 5. And that simplifies to 2 over square root of 5. Then we're going to rationalize the denominator by multiplying the top and the bottom by root 5. And the exact value for tangent of theta then is 2 root 5 over 5.